Hello students, welcome back. Section 3 of this notebook is Methods of Proof. I'm not exactly sure whether I can call it preliminaries, but I decided to include it anyway. In any case, we have to cover it in week 1, and it has to be included in week 1 module. Here we go. Method of proof. What do you mean by proof? You write down a mathematical statement, and then you have to argue whether that statement is true. And that's a proof. What kind of methods do we use? There are many methods, but roughly speaking, we can classify like this, as direct proof and indirect proof. And the direct proof into proof by manipulation, typically algebraic manipulation, and proof by logical implication. In this course, we're going to focus primarily upon the first one, proof by algebraic manipulation. I'm going to write a lot of proof problems in the exams and of course homeworks and so on. And most of the problem that you are asked to do in the exam will be algebraic manipulation, proof by algebraic manipulation. Basically, I want you to have some proficiency or some kind of mastery before moving on to the next level. We will do a little bit of indirect proofs as well, proof by contradiction, very few, proof by mathematical induction, a little bit more, but still relatively few. Proof by logical implication, and this is a vast topic, but we'll gradually go into this. This is not the kind of thing that you can just master in one semester. You need multiple semesters. Let's assume you're starting from here, and then the next semester, if you're taking Maths 30-20 or some other things, then by that time, you're going to get some kind of proficiency there. Anyway, that's my plan. Let's focus heavily upon the first one, proof by algebraic manipulation. Of course, it doesn't make much sense unless you see some examples, and here we go, all right? Remember, we are doing proof by manipulation here, all right? Some examples. Here's a good example. Prove that a plus b total quantity squared is a squared plus 2ab plus b squared. How do we prove that? This is really simple proof by manipulation. We start from the left-hand side and then apply algebraic manipulation. Many steps if necessary, and in the end, you're going to go to the right-hand side. Want to see the example? Okay, here we go. A plus b total quantity squared is nothing more than a plus b times a plus b. And then let's break up this parenthesis by foiling out. A times a squared, a times b, ab, and b times a is ba, b times b is b squared, we got that. And please note that ab and ba are the same, so we can combine those two together as 2ab, and that's the right-hand side. How do you like this proof? Start from the left-hand side and work out. In the end, you get to the right-hand side. The simplest type of proof. Sometimes you may have to work backward. Here's an example. You can work from the left-hand side, yeah, but it's easier if you start from the right-hand side. Why? Breaking up parentheses is easier than factorizing it back. Here's the proof. We begin with a plus b times a minus b, and then apply the FOIL method, the same thing. And then, please note, we have minus ab plus ab canceling each other out, eventually leading up to the left-hand side, a squared minus b squared. There goes the whole proof. Do you like this proof? Start from right-hand side, manipulate, and in the end, you get to the left side. This is a kind of thing we are going to do a lot in this course. How about a little bit harder example? Do you want to start from the left-hand side or do you want to start from the right-hand side? My choice is to start from the right hand side. Why? The same reason as before. It is easier to break up the parentheses than going vice versa and factorize. So start from the right hand side and then break up these parentheses. There are many terms, so we have some dot dot dot. So it can get a little bit tricky, but it won't be too bad. Maybe I shouldn't have done this. Let's do this. Okay, let's start from here. And then let's break up 8 times all this. And then minus b times all those. Okay, all right. So 8 times, which I am highlighting in blue, times that generated this part, and b, which I'm highlighting in red, times this part generated all these red terms. Okay, and then what kind of algebraic manipulation would you like to do? Break up everything? Okay, let's multiply 8 times a to the n minus first power. What is it? Nth power, b to the 0 power, all right. Plus, now 8 times a to the n minus second power. What is it? A to the n minus first power, b to the first power. Oops. Next one, a to the n minus third power times a, so n minus second power, b to the second power, and then of course all these, and then a times this one here, so we have a squared, b to the n minus second power, and finally a times that, so a to the first power, b to the n minus first power. This is what you're gonna get if you break all those up. And all these are coming from the first line, so let me emphasize those with blue. Okay, how about these? This negative sign, b times that, so we have a to the n minus first power, b to the first power, right? And distributing negative sign, a to the n minus second power, b to the what power? Now second power. And then what comes here next? A to the n minus third power, b to the what power? I have to multiply extra b, so we have third power, and so on and so forth. And we have to multiply this to that one, so a to the first power, b to the n minus first power, minus a to the 0 power, b to the nth power. That's the final one, isn't it? It may be a little bit difficult to align everything accordingly in handwriting, but I'm using computers, so it's a bit easier to align everything. If you align, it's a little bit easier to see things. Okay, a little bit further. Okay, so what do we have? All these blue generated these blue. All these red generated all these. Okay, and then please note that this one minus that one cancel each other out. This one minus that one cancel each other out. All will be cancelled out from here all the way over there, and we have only the first and the last term left. Does it make sense? A to the nth power, b to the 0 power. 0 power, you don't have to write it. Let's write it anyway. A to the 0 power times b to the nth power. That's the same as to the nth power times 1 minus b to the nth power. And what is that? That's left hand side. And this completed the proof. So what did he do? Start from the right hand side and we apply the algebraic manipulation. Sometimes those algebraic manipulations can get a little bit tedious, as you see in this case. And sometimes you may lose track of what you have been doing. But if you keep your first step, appropriate setup, then you can handle it all right. By the way, the answer is in here, but instead of just showing you the answer, I thought it's going to be easier for you to follow if I just go through these again. Okay, last problem, I'm going to leave this as an exercise to you. So basically f of x is equal to x to the nth power, then what am I doing? The derivative is limit h is going to 0. Okay, all right. f of x plus h minus f of x over h, isn't it? The difference of y coordinate over the difference of x coordinate. This thing is often called the difference quotient or Newton quotient. And if you apply appropriate algebraic rule here, you're going to get what you want. But let me just take one more step for help. So this is nth power function. So what is f of x plus h? It's x plus h to the nth power. And what is f of x? Is x to the nth power. And basically, this is what we have to do algebraically. Manipulate this one, and then take one step after another. And you have fabulous tool already. Let me expand the font a little bit. We have nth power minus nth power, and we have done this one. So you can use that. In the end, what do you get? Well, I'll stop here. I want you to work out. This problem, by the way, does not have anything to do directly with linear algebra, but it does help you polishing your proof by manipulation. So I'm kind of torn. Shall I write it as a homework problem? In the end, I decided to, well, go against it. Okay, I'll just leave it as a voluntary exercises for students rather than asking for this, because there are going to be plenty of algebraic manipulation. There are going to be plenty of proof by manipulation starting from the next semester. But if you really want to brush up your skill, it may be a good idea to try these when we have the answer keys. So all the answer keys are actually here in this notebook. I'm not showing you in this video lesson, but actually there are. See? Answer key is here. Let's see, how much time do we have? Maybe just one more example. No, excuse me. I'll resume these two, example 313 and example 314, in a separate video. Let me stop here.